Here we'll be introducing additional knowledge about the use of data providers. With that in mind, we propose a practical implementation in our application. Let's suppose that the travel agency awards each customer who has bought more than 3 tours with a special full services card that they can use to enjoy all services for free. Customers who bought 3 tours or less are entitled to a card of the partial services type. So, we have the customer transaction that enables us to record for each customer the corresponding data along with the tours made. And also, the service card transaction that defines the cards. Each card has an identifier that is auto-numbered, a customer, and we've defined the service card type attribute based on the enumerated domain type, which only allows for values full or partial. We also defined the WP Cards web panel that offers a button to trigger the automatic process for generating and viewing new cards. So, what will occur when we press the button? A card of the corresponding type will have to be created for every customer who doesn't have an issued card yet. To do so, we must bear in mind the number of tours the customer has bought. We propose a solution using a data provider that will load and return the collection of cards to be generated. And then we go over the collection and save the cards in the database. And how do we do this? To start with, we set up the service card transaction as business component in order to save the cards using the business component concept. Then we create an object of the data provider type called DP cards, and we drag the service card transaction over the source of that data provider. What do we see now? A syntax identical to the one generated when we drag a structured data type over the source of a data provider. And we can also see that we can apply this to drag a transaction that was declared as business component. In this particular case, we did not define an SDT in the knowledge base, but the syntax leads us to infer that a structure will be loaded in memory with items that have the same name and type as the attributes of the service card transaction. We should remember that these are not attributes, but rather the items of the structure that will be loaded in memory. The idea so far is that cards will be loaded in memory, but starting where and under what specific conditions. We must go over the customer table, filter customers for whom a card has not been issued yet, and add a card in the collection for each of those customers. The base table of a data provider, that is, the table for navigating, is determined by the attributes we reference to the right of the assignment signs. It is clear that, to the customer ID item, we will be assigning the customer ID attribute. We do not need to assign any specific value to the service card ID item because, considering this structure was dragged from a BC Valor transaction, then this item is based on the service card ID attribute, which belongs to the ID domain, and its auto-number property is set to yes. We should now see that, to service card type, we can assign the value returned by a conditional formula, meaning that the formula will return the full or the partial type according to the number of tours that the customer has bought. Note the attributes appearing to the right of the assignment signs. It is only customer ID because the attributes inside the formula are not taken into account for determining this base table. They determine the table to be navigated by the formula. So, the table navigated by the data provider is customer. However, we do not want to navigate all customers and load a card for each of them. We only need to go over those customers who do not have a card yet. Data providers enable us to include in their syntax all the clauses allowed in the for each. So, we will add this where clause. This is how we can navigate all customers whose number of cards is 0, that is, they don't have any cards. But if we take a closer look at this where clause, Since the only attribute referenced is inside a formula, it will not participate in determining the base table of the data provider. If it had been evaluated directly, then it would be participating. So now, if we observe the data provider, we will see that we can simplify it a bit more. When an item in the structure of a data provider is loaded with an attribute with the same name, then we can abbreviate the declaration like this. Now let's analyze the output of the data provider. When we dragged the service card transaction, the output property was automatically associated with it. And what about the collection property? The structure we're loading does not represent a collection. It only represents an instance in memory, with the structure of one record of the table associated with the service card transaction. But we need to obtain a collection of cards generated. So, we set the collection property with true value, and indicate a name for the collection that this data provider will return loaded. Let's go back to the web panel to invoke the data provider. In the enter event associated with the button, we declare a service card collection variable. That GeneXus defines automatically as a collection of service card because it includes the term collection in its name. The enter event will then be this. Now let's go back to the web panel's form to insert the service card variable. Due to the fact that it's a collection variable, GeneXus automatically understands that it has to show the content on a grid. But is this enough for the cards that the data provider returns to be actually recorded in the service card table associated with the service card transaction? No, it isn't. So far, the cards are loaded in memory, and we have shown the content of the collection. When we studied the use of transactions as BC, we saw that in order to save and record, we must use the save method and then execute the commit command. So, we still have to go over the collection returned by the data provider and save each element in the collection as a record on the physical table. And only then, after all cards have been saved, we must declare the commit command. For going over the card collection returned by the data provider, we have the for element in collection command. This variable, one card, must be defined. It will represent each element that is iterated from the collection. Let's define it. Now let's return to the event so we can complete the code that runs through the collection. Now the development of the requirement is complete. Let's press F5 to see the behavior. Then we execute the web panel, press the button, and on the grid we see the list of cards that were generated. Now let's execute the service card transaction to verify that the cards have been actually saved as records. So now we could wonder, what will happen if we press the Generate Cards button in the web panel once again? Will this create cards again for the same customers? No, that will not happen here because in the data provider, we filtered that we only wanted to navigate customers who did not have a card, and we can verify that this is so. We press the button again, and we can see that this time, no cards are generated. To end, we should mention that GeneXus offers other solutions to solve this requirement also. In this implementation, we used the business component concept to update the database, and benefited from them, and combined the use of BCs with the collection structure previously loaded in memory with the data to be recorded. The use of a data provider in this case is very simple and saves us the work of having to write explicit code.